This is Alper Işleyen from TUBITAK, the National Metrology Institute of Turkey. I am working as the head of the Reference Materials Laboratory at TUBITAK. Today I am going to help you explaining how reference materials can be used for uncertainty estimations. There are two alternative approaches to estimate uncertainty. Here you can see one approach is the bottom-up approach and the other one is the top-down approach. In the bottom-up approach, according to GAM, you start from the model equation and consider all individual contributions to the equation. And in the top-down case, you have the result in hand and you are using the validation and quality control data, assuming that they cover all influence factors and they have the representative for all measurements with this method. Let me show you the main differences of these two approaches. Here you can see in the top-down approach you need the validation data and it is necessary to know the reliability of the method, and you need to know if the method was performed satisfactorily, and if these are the cases then you can use your data to estimate the uncertainty. And in the case of the bottom-up approach, all factors influencing the measurement should be taken into account, and all factors influencing the result will be very well known, and it is necessary to know the method very well in detail, because you are going to build up a fishbone approach to create and find the uncertainty. And here are now the advantages and disadvantages of these two approaches. The top-down approach is easy to apply. Underestimating risk is low, and because it is depending on the real performance. However, it doesn't give any information to improve the method. This is the disadvantage of top-down approach. And now the advantages and disadvantages of the bottom-up approach. It of course helps improving the method. It indicates how well the method is understood, and scientifically this is the elegant approach. However, this is more complicated approach and requires more research, and there is a risk of not including very important parameters influencing the result. Nordtest is a Nordic corporation working in the field of conformity assessment for Nordic countries. They are preparing very useful guidelines and very useful books, especially for the uncertainty estimation and also for internal quality control. Here is the website. You can reach their documents, and according to this Nordtest, uncertainty can be split into two main parts. One is the reproducibility precision and the other one is the bias trueness. Reproducibility can be obtained by measurement of control samples, whereas bias, the trueness, can be obtained from the data from the measurements of reference materials or from a comparison measurement of different laboratories or through a standard addition approach. So by combining these two like this with this equation given here, you can reach the overall uncertainty of a measurement. Let me show you what is necessary for the top-down approach to apply. Here, uncertainty estimation will be done using the standard deviation and delta from a validation of measurement procedure by means of a certified reference material. The precondition to apply this is that the composition of the samples should be similar to that of the CRM in order to be able to apply the validation data for the future measurements. Parameters, as I said before, are the S, the standard deviation from for the precision, and delta for the trueness. And here are how we can calculate these. A mean value of X from n single measurement results under repeatability conditions as those expected for further measurements. Certified reference value will be obtained from the CRM certificate, and systematic deviation will be calculated, which is also called the delta, from the mean value of the measurements of the CRM minus the reference value. And standard deviation can be calculated using this equation. Of course, you can use Microsoft Excel to calculate standard deviation easily. Now I would like to show you how uncertainty of delta can be calculated. Here you can see for the 95% coverage interval you have to find the 2u delta, which can be calculated through the measurement results of the CRM, standard deviation square divided by the number of measurements, plus the uncertainty of the certified reference material, and by combining these two you can reach 2u delta. And we have already seen in our part 2 of our training that how significance test can be done. Delta is compared with 2u delta, and if it is smaller, then there is no significant difference between the result and the certificate of the reference material, and if it is bigger, then it means there is significant difference in this comparison. If delta is found to be significant, then one option is to do a correction on the measurement result. You can do a correction on the measured result by using this equation, and you can put the influence of delta and calculate the new result. However, to do this, you have to be very sure about the delta is systematic over time. It is a repeating condition, like always finding 10% higher results in the measurements. If it is the case, feel free to do such a correction, but if it is not the case, don't use this. And in this case, to the uncertainty, we are not putting the influence of the delta. As you see here, uncertainty is composed of the repeated measurements of the samples, repeated measurements of the certified reference material, and the uncertainty of the certified reference material. In the second case, delta is again found to be significant, but this time we are not going to do any correction for the result. Instead, we are going to do correction on the uncertainty. So we are going to add the influence of the delta to the uncertainty. You see the components again: repeated measurements of the sample, repeated measurements of the CRM uncertainty, plus this time we are going to add the influence of delta to this equation and combine the uncertainty, and by this way we are going to have a bigger uncertainty, but we are not going to do any correction on the measurement result. Are all these calculations confusing for you, those squares, square roots? Then I would like to show you another alternative, a free software to calculate the measurement uncertainty. It is called MUKit. It is Measurement Uncertainty Kit, developed by the SUKE Finnish Environment Institute, and it's a very useful tool to do uncertainty calculations in a standardized way. So let's get familiar with this program. You can download the program through the link given here and install it to your computers. And here in the first page, the program asks some important information from you about your measurand, about your method, about the analyte matrix and the unit of measurements. And after collecting this data, then the software is asking you how you are going to you want to calculate the within laboratory reproducibility. Options are a control sample covering the whole analytical process, or control samples and routine sample replicates. From these data, the software can calculate the influence of the within laboratory reproducibility. Of course, it also asks the lower and higher limit of your method. After obtaining information about the reproducibility, the software is asking you to give information about the laboratory and method bias. For the bias, here are the options from the drop-down list. You can select, you can use certified reference material, you can use an interlaboratory comparison or proficiency test, or you can use recovery test data. So if you select the certified reference material, then this page comes, and on this page you can introduce a CRM. Here you can see standard deviation of the measured concentration is asked, a number of measurements of the CRM is also asked, and the certified concentration of the CRM you should put here, and the standard uncertainty of the certified concentration you should put here, and here is the place where you should put the measured concentration of the CRM. So after completing this, you should press add and put the CRM on the list. And the good thing is, if you have even more than one CRM to control your measurements, then you can add another CRM also to the list, and then when you are finished, you place calculate uncertainty. When you press the calculate uncertainty button, the software automatically creates you the calculation, and here you can see the result of the calculation. Here 14% relative uncertainty is the result of this calculation, and you can see more details on the calculations. You can see all the details how the uncertainty is calculated. There are different reporting options. One I am showing you is the detailed node test report format, and there are also simpler reporting versions available, but this is a good format to show to the assessors how the uncertainty is evaluated and calculated. All equations are here, so you can see how the software is calculating the uncertainty, the overall uncertainty as a final result. And last, I would like to say that further information about MUKit is available as reading, and also a tutorial video about how to use MUKit is also uploaded. Dear colleagues, we come to the end of our course. I hope you enjoyed the content of this training, and information you learned in this training are useful and applicable to your daily work. You can send me your questions about the training. You can also reach me through my email address given here.